Hello and welcome to a new video about using open source software to operate a CNC. In this episode I'm going to talk about a very useful operation, the V-Carve operation, also called Medial line engrave. Why is it useful? Well, I guess you have been in my situation as I've been when I first started my CNC. I first turned it on. A lot of projects involved carving, some design, some letters, some graphics on a piece of wood. Well, I told myself that should be easy, so let's go do it. It isn't really that easy, and if you want to get good results, you will see that it gets pretty complicated, unless you know the correct software to use. As you know, I'm only using open source software, so this is free software, you can use it even for production, there's no limitation here. So stick with me and I will show you how to get the best V-Carve, the best way to V-Carve things, because even though it sounds easy, for certain things such as very wide graphics, things get complicated. Not in Blender. In Blender everything works smooth. Most probably you are going to use an SVG graphics. I'm going to use the same SVG graphics that I have used for the previous video, the one about intarsia or inlays. I'm going to import it in Blender and show you how easy it is to use it to make V-Carve, a very beautiful V-Carve. Make a couple of clicks and you will have the G-code ready to go to the CNC and mill your project. But before starting, I have to thank everybody for watching my videos, for subscribing to my channel, for liking the videos, for commenting on them. No matter how positive or negative the comments, they are very helpful. They help me get better with each video, or at least I hope so. And of course I won't forget the ones that subscribe to my Patreon page, and if you want to do the same you can find the link in the description. There you will find a lot of useful things, some of them are free, some of them are available to the members. And now let's get moving. Along the video I will tell you what are the differences between FreeCAD and Blender and why I like to do this in Blender. I wouldn't even think about using FreeCAD anymore for this type of thing. So I'm in Blender 4.2, I'm using the latest BlenderCam add-on. Now let's first import the file, go to the file menu, click on import and select scalable vector graphics. I have this very nice design that I will import. Here it is placed random, I believe it has something to do with how the file was saved. The first thing that I encounter is that it is created out of a lot of small curves. You can see here a lot of objects, so select all the curves and press Ctrl J. Now they have all been turned into a single curve. It's easier to move it around, so let's place it somewhere close to the origin. And because the origin of the SVG is here and I want it to be in the world origin, I will select it, go to object, go to set origin and click on origin to 3D cursor. Of course making sure the 3D cursor is in the world origin, but since it's a new document it should be there. After that, the first thing that I want to do is to make sure the curves are okay, there are no double lines one on top of each other, because this might generate some issues later. So open the side menu from the left, scroll down to the curve cam tools, and here I have a button, remove curve doubles. You can also specify a merge distance larger than 0 if there are lines which are very close together but are not perfectly overlapping. I will try first with the value of 0, click on OK. You can see the inside, the faces have disappeared, but that's not a problem because for what I'm going to do it's okay like this. So let's go to the right, go to the render tab, change the render engine from Eve to CNC Cam. It used to be called BlenderCam, but now it's called CNC Cam. So if it's not called CNC Cam, go and download the latest update and install it. In case you are installing it in Blender 4.1, you should know that most probably the latest update won't work, so you also have to update Blender to 4.2. Before making any operation, I will scroll down here to the tab called Cam Machine, because I want to make some settings for my machine. After doing this a couple of times, you will save a preset and you will already have everything set up. Let me show you how to easily get the settings here in order to avoid some problems later. The first thing that I see here is that everything is in meters. Well, I'm using a CNC, I want to have everything in millimeters, so I'll go to Scene and change the length from meters to millimeters. Now go back to the render tab, scroll down again to the Cam Machine, and now I have millimeters here. Depending on where you live or on what you're used to, you can change the unit system from metric to imperial. I am using metric, and let's define a work area. I will enlarge enlarge this a little bit because you can see something that I believe it should be a bug, because it writes 790 meters. In fact, the field is too small and the second M from the millimeters doesn't fit. I think this should be aligned to the right in order to see the unit first, but that's not the idea right now. Let's set the total work area of the CNC. My machine has a work area of 790 millimeters by 790 millimeters, and the height, the total movement of the cutter head is 210 millimeters. This doesn't really matter because it will generate the G-code outside of this box. This is the CNC machine, the work area. BlenderCam has no problem to generate G-code for pieces that are outside of the machine space. It will show you a warning, but it will generate the G-code without any problem. Still, I believe it is a safe thing to do to make sure that everything fits on your machine. So set the work area correctly according to whatever machine you have. The next settings that I'm going to make are the feed rate minimum and maximum. Why do I need to change this? Because no matter what I set in the operation, it must be in this range. So if I had a feed rate maximum of 1000 millimeters per minute and I set an operation with a 3000 millimeters per minute feed speed, it will be automatically reduced to the maximum feed rate of the machine. So make sure you have a correct feed rate here. I will leave it to 6500. The default feed rate, you can also change it, so you won't have to change it when creating operations, but this can only happen in situations when you have a lot of repetitive tasks. Otherwise, most probably for each operation you have to set a custom feed rate speed. I will write 2500 millimeters per minute value. The same that I've told you about the feed rate applies to the spindle speed, because if the spindle speed that you set in the operation is outside of this range, it will be modified automatically to the closest one. If it's higher than the maximum, it will be reduced to the maximum. If it's smaller than the minimum, it will be brought to the minimum value. 5000 to 30,000 is okay for my machine. In fact, my machine has a maximum spindle speed of 24,000, so let's modify it here. I also have to set a spindle start delay in seconds. It's the time between the moment that the spindle starts rotating until it reaches full speed. For my machine, I have set it in the fluidency to 6 seconds, so I will also set it here in BlenderCam to 6 seconds. The cutter won't move until it reaches full speed, otherwise it might start cutting without the spindle reaching its full speed, which might lead to bad results, to damage the cutter, breaking tool bit, maybe damaging the spindle. So it's safe to use the same value here. The spindle default RPM, I will leave it at 15,000, even though I usually use a higher value, 18,000 or 18,500, but again, depending on the situation, the spindle speed varies, so the default isn't really that necessary. The tool definitions, the tool change commands, these are for more advanced machines. Mine doesn't have an automatical tool changer, so I won't be modifying this, just leave them to the default values. The collet size is something that might seem very useful. You can see the description, collet size for collision detection, which is a very nice thing. You might believe that when the cutter moves around and tries to mill something, if it detects that it will hit with a collet something, it will stop. It won't for now, at least, because there's something missing in the settings. When you are creating a tool bit, you cannot define a height of the tool bit. So since I don't have a height of the tool bit, I will never know where the collet is, so having its dimension has no point at all. But probably this option is set here because it will be implemented somewhere in the future. And if you do this commercially, you have a really useful tool here, a price per hour. You can set a price no matter the currency is just a number, and BlenderCam will automatically calculate based on the time of the operation the total value for a project. So if somebody asks me how much would it cost to make a V-Carve operation for this shape, this design that I've loaded, I can easily tell them the price in just a couple of seconds after setting the operation. I will have the total price shown there, so I can make a correct quote immediately without the risk of losing money or maybe overcharging and losing a customer. One thing that I forgot to modify because it was already set as required for me, but it's important to know that you can also change the post processor. You have a list of post processors here. I'm using GRBL, so this is okay for me. And now, after setting the machine, let's scroll up and start creating the V-Carve operation. Make sure you have the curve selected and click on this button here under the CAM operations. Click on the plus button, which will create an operation called curve. It's the name of the object that I have selected, op before from operation and 1 the number of the operation. Now let's start scrolling down and make all the settings so you know how to set everything up in order to get the correct result without any trouble. The first tab that I'm going to stop is CAM material size and position. I will leave the estimate cut area from model checked so I don't have to set the dimensions of the material by hand. Sometimes you might want to do that, but for now Blender CAM simply doesn't take into account the material size. It only takes into account the dimensions of the object that you are milling, so no matter how large or small you set the material, it will simply cut the entire object that you want to cut. The next tab, the CAM operation setup, has 3 main values: number of axes, which I will leave to 3. The strategy, I have to change it. I'm going to use a medial axis operation. The 2 values behind the strategy that have appeared, they are specific for each type of strategy. Try to leave them at the default values. Leaving them just as they are most probably will get me some good results. If I'm not satisfied with the G-code generated, I can try to modify them a little to get higher accuracy or faster speed, depending on what my problem is. One of the most important things that I have here is this checkbox, the add pocket operation. Let me zoom in a little bit here and I will explain you exactly what this means. You can see here at the W, the width is very large. Most probably my cutter tool bit, my VCarve tool bit, is smaller than the distance between these 2 lines. One great thing about the VCarve operation in Blender is that whenever the graphics is wider than the tool bit, it will generate 2 passes, 1 on each side, and in the center there will be some material left. Checking this button will generate another curve. After processing this operation will generate another curve that I can use to remove that material. When we will process this operation, you will see the generated curve for the pocket operation and how to set everything up in that operation too. In case you are making a project that involves multiple copies of the same project, you can check this box, use array, and you will have some values here: the X count and the distance between the objects, the Y count and the distance between the objects, so you can mill multiple items at a time. It's a very useful thing when you are making production. For example, if you are making some coasters, I will uncheck it now because I will only make a copy. At the CAM optimization tab, I will leave everything as is. I will only check the simplify G-code button with a default tolerance. I've tried modifying it and the results are pretty odd, so it's very useful to check it, but leave the default tolerance as it is. Moving on to the CAM operation area, I have several options here. The first one is use layers. I will leave it checked and I will set a layer of 2 mm because otherwise the generated toolpath will include some very deep plunging and that might damage the object, the CNC, the tool bit. It's preferable to use step down. Depending on your setup, you might use a larger value or smaller value. That is up to you and I'm not going to talk too much about that right now. When using Blender CAM, you have to know that always the default depth start will be set to 0. I'm used to setting the 0 to the table of the CNC and the object will be over 0. This time I'm going to mill a piece of wood of 20 mm thick. I'm going to set the operation depth start to 20 mm. I now have a warning here, an error, a collision, because the free movement height, which is the height at which the cutter moves when it doesn't mill, I have to make it of course higher than the depth start. I'm going to use 35 mm now. The warning is gone. When making VCarve, you most probably want to limit the depth of cut, the total depth of cut, depending on the material, on the total thickness, on how do you believe it will hold on later. So setting max depth from object will end the operation at the lowest point of the object. In my case, the object is set to 0, so it will do the VCarve from 20 mm to 0 mm, which is way too much. I want it to be just 3 mm deep, so I will change the set max depth from object to custom. Since my operation is starting at 20 mm, I will write 17 and this will result in a maximum depth of 3 mm. The next tab, the cab movement tab, has has some settings about the direction of the tool bit, but since this is a V-Carve operation, means the cutter is engaged on all sides at any given time, so no matter if I set the movement to conventional to climb, it will be climb on one side and conventional on the other side. Again, another setting for the free movement height, which you can see it is synchronized with the one above, so it's a redundant setting and I'm not going to modify it from here. The stay low, if possible, is an option to avoid raising the cutter head to the safe height if the path is not going to make a collision with a stock, so you can leave it like this, but don't change the merge distance because this will result in some wrong movement. I've tried it and had some weird results. I will also leave the protect vertical as it is, 4 degrees vertical limit. This means that any slope that is between 86 and 90 degrees will be treated as a 90-degree slope to avoid damaging the tool bit. For the feed rate, I will change the value to 2200, but that depends on the machine, the tool bit and the material. In BlenderCam, the plunge speed, which is the speed of the movement on the z-axis, is expressed as a percentage of the normal feed rate on x and y. It is default set to 50%. Depending on the material, you might want to change that. The plunge angle is the angle that it considers from that angle on. It considers that it is a plunge, and BlenderCam will use the plunge speed, which can be lower as I've told you earlier. Also here I must set the spindle speed, the RPM, 18,000 should do it. And let's move to the next section, the cam cutter section. I have a couple of presets here. You can see there are a lot of ball ends and cylinders, and for V-Carves this is a custom tool bit that I have created myself. So let me show you how to do that. Go to the cutter and here I have several shapes. For the V-Carve operation I will select a V-Carve shape. The cutter angle is the angle between the horizontal and the edge of the cutter. It's not the angle between the two lines of the cutter, but between the horizontal and the edge. In my case I have a 90 degrees tool bit, which translates to 45 degrees to the horizontal line. Its diameter is 10 millimeters and the number of flutes is 2. Let's write a tool description. 10 millimeters V-Carve, 45 degrees. I will select all this text and press Ctrl C, because when I click on the plus button to add it to the presets, it will ask me the name and I have to write it again. So press Ctrl V, and now I have this tool bit. I can use it in any other job from now on. It will always be in this library. The only option that is missing from here is the cutter length, which, as I've told you earlier, is a problem because you cannot detect collision if you don't have the length of the tool bit. Moving on to the next tab, I have the cam GCode options. I will only check the output GCode trailer, because if I don't check this and have here written M02, after finishing the operation on my GRBL machine, the spindle will keep on spinning and I have to manually turn it off. Writing here a M02 command at the output GCode trailer will stop everything, so you need to do this. The dust collector, hold down and mist options are also here, but I'm not using any of these, so I will skip over. Now we have reached the cam machine, so we are ready. We can scroll back up, and in the cam operations I have this operation that I have just set up. Click on the calculate path and export GCode button. It takes a couple of seconds, but a very short amount of time compared to other programs to calculate the path and to also generate another operation. I will show you immediately. As you can see, I have another operation here, which is called Medial pocket. I also have the curve here, and if we take a look from top, you can see that it is a curve inside of the curve that I'm trying to mill, because here the V-Carve tool bit will remove the material, but I still have to remove all this material from the inside. So now I have to scroll down and set also the values for this operation. I will check the estimate cut area from the model because I want to mill the entire surface. Leave the strategy to pocket. It has been automatically set when creating the initial operation, and I only need to change a couple of things, which are the use layers. I will set a value of 2 millimeters just as for the V-Carve operation, and the most important things that I want to set are the operation depth start, which by default is 0 millimeters, and I don't want to happen that since my origin is set below the material that I'm milling. I will use a start depth of 20 millimeters. The free movement height I will set it also to 35 millimeters, and one more thing that I really need to change is the set max depth from, because since it is from material it will stop at the bottom, so I want to change it to custom and set the same depth as I did for the V-Carve operation, set a 70mm max depth, and now this operation will mill all the material that remained inside all these shapes from the previous operation. Now I can scroll down and go to the cam feed rate, also change these values, change the plunge speed, change the spindle RPM. And the last thing that I want to change is the cutter, because it uses the same V-Carve cutter that I have used for the previous operation. I don't want that. I'm going to use a 3mm end mill. And now after setting the cutter, I can scroll back up and click on the calculate path and export G-code button. You can see now the operation is correctly placed at the correct height. I have the 2 layers required to mill the 3mm. I can now take the files and go to the CNC to mill this model and see what turns out in the end. But how do you find the files? It's kind of difficult if you haven't saved the file. You can see here my file isn't saved and I find it difficult to find the G-code files. So in order to do that, I will first save this file and the G-code files will be in the same folder. So go to Blender, save the file as wine VCarve.blend, save the file, and now I can click again on calculate path and export G-code for the first operation. Now select the second operation, click again on the calculate path and export G-code. I could have also clicked only on the export G-code operation because I didn't really need to recompute all the operations, but I missed this button. So remember, there's an export G-code button if it didn't export correctly because you hadn't saved the file. After saving the file, you can click on the export G-code. So it's that easy to create a VCarve operation in Blender. I will show you another example without explaining all the settings that I'm making for the operation, simply to show you how quickly you can set everything up in just a couple of seconds. So let's create a new file. Let's import this very nice skeleton since Halloween is closing in. So I have several curves, select all of them, press Ctrl J to join them into a single curve. Now open the left side menu, scroll down to the curve cam tools, click on the remove curve doubles, leave the default merge distance of 0, click on OK, and now I have the correct outline. Go to the Blender cam, select the engine to CNC cam, scroll down and make sure I have the correct machine. Now with the curve selected, press on the plus under cam operations. Let's take all the settings one by one quickly. Strategy, medial axis, simplify the G-code, change the scene from meters to millimeters. It's quite annoying that it always switches back to meters, so I will use layers of 2mm. I will start the operation at 20mm with a free movement height of 35. Set max depth custom to 17mm. I will use the same values as in the previous example. Leave the movement as is. Change the feed rate to a higher speed for my machine. Also change the plunge speed and the spindle to 18,500. Select the proper tool bit, the 10mm V-Carve 45 degrees that we have set earlier. Check the output G-code trailer. The M02 is by default filled here if I have already written it once. Now I can scroll up, click on the calculate path and export G-code, and now I have the G-code for this operation. Let's see the medial pocket. You can see here highlighted in white, so we need to make also this operation. Check the estimate cut area from model, scroll down to cam operation area, check the use layers, write the value of 2mm, make it start from 20mm with a free movement of 35. Change the max depth from material to custom and set a value of 17mm. Go to the cam feed rate, set a correct feed rate. Also change the plunge speed, the spindle RPM. Select the proper tool bit. I will use a 3mm end mill. Check the output G-code trailer and make sure M02 is here. Now scroll up, click on the calculate path and export G-code, and I have the operation for this too. Of course, there are some differences because the medial pocket, if you take a look at it here, it still has some milling to do inside of these areas, but they are very thin. I probably should have used a much smaller tool bit. A 1mm tool bit should clear almost everything. Go back to the medial pocket operation, scroll down to the cam cutter and change it from end cylinder 3mm to a 1mm end cylinder. And I need to change the layer to 1mm to avoid breaking the tool bit. Now scroll back up and click again on calculate path and export G-code. You can see now it goes much farther into the material, so most probably everything will be removed and the pieces that remain here are going to be so small that they are barely visible, or at least I hope so. We will see that when we go to the machine and mill everything. So in just 2 minutes I have managed to take a file, import it, generate the G-code for the VCarve for the outside, and then the G-code for the pocket to remove all the material remaining in the inside. I think it's incredibly fast. The results are awesome. It takes into account a lot of things. It does the medial line if it is possible, considering the width of the graphic and the diameter of the tool bit. If the diameter of the tool bit is not enough, it will change the strategy automatically to mill the outsides and then generate the curve that I need in order to mill the remaining material in the center. Let's save this file too. Let's name it Halloween skeleton. Save the file, and now I can go here and select each of the operations and simply press export G-code. And now let's go to the machine and mill these designs to see how they turn out in the end. So here it is after around 35-40 minutes on the CNC. This is the sign. Could I have done it better? Of course, because there are a lot of things that I haven't done properly when setting up the machine. I will explain in another video what I did wrong or what I didn't do, because there were some things that I had to do and I didn't do because I wanted to get this project done. I also used a 3mm end mill and I should have used a smaller one, a 1mm end mill, because that would have cleared much more material from what has remained between the VCarve toolpath. But I think it's okay with just a little of cleaning. It will be a very nice sign. So this is a way to make the toolpath to generate the G-code for VCarve in Blender. Don't forget to subscribe to my channel, and if you want to support me, you can anytime find the link in the description to my Patreon page. Thank you and see you next time.